Hey guys, so in this video we'll be looking at parallel lines, and we'll look at proving if two equations or two lines are parallel, and also finding an equation of a parallel line. But before we get started into finding out whether two lines are parallel or how to find the equation of a parallel line, let's determine what a parallel line actually means. So a parallel line are two straight lines that never meet, alright? And they have the exact same gradient, so they're right next to each other. Right, so therefore the gradient of one line must equal the gradient of the second line. So they have the exact same gradient. And also they do not intersect. Okay, so that's when two lines are parallel. When they don't intersect, they have the exact same gradient. So think of train tracks, right? If you've got the tracks going all the way through, so I'm not talking about, so I'll just draw it up so we can get some sense into it. So I'll just draw up two lines, and obviously that's what a train track looks like. It's a bit like a ladder. Okay, and these lines over here, I'll put it in green. I'll just overlap it in green. These lines over here have the exact same gradient. I know they don't look straight in the picture there, but if you think about train tracks, they're right next to each other, but they never intersect. Right, they always keep going straight along down that path, but they never intersect, and that's what parallel lines actually are. Right, they're two lines that have the exact same gradient and don't intersect. Alright, and now we'll look at having two equations and determining whether they're parallel or not. So write down two equations. I've got 2y minus 4x equals 7, so that'll be my first equation, and my second equation will be 5 over 2y minus 5x equals 15. Okay, and we're going to try to determine whether these two lines are parallel or not. Okay, so I'll take equation 1 and I'll rearrange it to make it look like y equals mx plus c. So I get 2y equals 4x plus 7. It's obviously taking that negative 4x across, and it becomes positive. So therefore, if I divide both sides by 2, so I divide by 2 over there, and divide over here by 2, and divide over there by 2, I should get y equals 2x plus 7 over 2. And therefore my gradient for this equation is 2. Okay? Now, whoops, I'll take my second equation. Okay, so 5 over 2y equals 5x plus 15. And obviously if I want to get rid of this, I have to multiply it by the reciprocal on this side. Reciprocal is the fraction flipped over. Okay, therefore that will go away. And therefore I should get, so 2 times 5 is 10, 10 divided by 5 is 2x, then 15 times 2 is 30, 30 divided by 5 is 6. And the gradient for this is also 2. So therefore we have just proved that these two lines are parallel. So you've just proved that two equations are parallel, and you just have to determine whether the gradients of both those equations are exactly the same. Well, now let's try find an equation of a parallel line. Okay, so I'll just go down a bit. Okay, so over here we're going to try to determine whether an equation is parallel line. I'll do it in a different color. So we want to find the equation of a line that passes through a point 1 and negative 2 and is parallel to the equation 3x plus 4y equals 4. Okay, so we want to find an equation that is parallel to this equation over here. Okay, and it passes through the point 1 and negative 2. Well, first things first, we should find the gradient for this equation over here, and we will rearrange it. So we've got 4y equals 4 minus 3x. Now divide this by 4, divide this by 4, and divide this by 4. So if I simplify that out, you got y equals 4 over 4 is just 1, minus 3 over 4x. Now we have found our gradient over here is negative 3 over 4. We have determined the gradient. Well, now we need to find the equation. Now to find the equation, we'll have to use our straight line, general straight line equation formula, and I'll be using y minus y1 equals m bracket x minus x1. The reason why I'll use this is I've got a coordinate point I know it will go through, and I have a gradient. Cool? Just makes it easier. So I'll go and substitute in my y, x, and my m. So y. So I've got negative 2 over there, so it becomes negative or minus 2. Okay. Equals negative 3 over 4 as my gradient. X minus 1. Okay, so you substitute in that. So that therefore this becomes y plus 2. Okay. Equals negative 3 over 4 bracket x minus 1. Cool, and we'll simplify it out. Cool, so I get y plus 2 equals negative 3 over 4x plus 3 over 4. Cool. Now I'll take my my 2 across, so therefore it becomes y equals negative 3 over 4x plus 3 over 4 minus 2. Alright, and I'll convert that to a fraction, that negative 2 to a fraction, so it's easier to solve. So y equals negative 3 over 4x plus 3 over 4 minus, and that should become 8 over 4. So it has the exact same denominator. Alright, therefore I can now solve that. Y equals negative 3 over 4x minus 5 over 4. And I have just found an equation that is parallel. So this, I'll draw it over here, is parallel to the original equation I had was 3x plus 4y equals 4. In other words, it was y equals negative 3 over 4x, and the y-intercept over there was 1 plus 1. So it's parallel to this equation over there. And that is how you determine a parallel equation or finding an equation of a parallel line.